Hello, everyone. Today for PyData Global, we're up for another exciting talk on effective Gen AI evaluations and how to mitigate hallucinations and ship fast. So, Atin is going to be presenting this talk. He's a co-founder and CTO of Galileo. So, without further ado, please welcome Atin. Hi,
Hey,
Atin.
Mark. Hi, how are you? Thanks for having me.
Okay. Yeah, thanks for coming on.
Yeah,
Yeah, please show your slides and I'll step off.
fantastic. All right. Hopefully, everyone can see my screen okay. And yeah, welcome everyone to PyData Global 2024. And I really appreciate the time you've taken to attend this talk. Hopefully, I'll make the next 30 minutes worth your while. And today I'll be essentially touching upon some practical methods to detect hallucinations, but also I'll give you four sort of frameworks to think about when you're designing your own sort of hallucination detection methodology, and dive into some of the more advanced sort of technical details without we only have time for a 30-minute talk, so I'll try to refrain from going too deep, but always happy to take more questions offline, and I'll share my email address at the end as well. So just a bit about Galileo and myself. So I've spent pretty much all of my career building and leading machine learning engineering teams at some of the larger companies, more advanced technology companies like Apple and Uber. At Apple, I was part of a very early Siri team, which built out the first few versions of the assistant. And from there, I moved to Uber, where I was leading various machine learning efforts as part of the Michelangelo team, which essentially was Uber's one-stop shop for all of Uber's AI and ML. So productionized hundreds of advanced AI models, built the first feature store, which became standardized infrastructure for ML ops, and founded Galileo. And at Galileo, I lead all of engineering and research. About Galileo, we kind of started close to getting to 4 years at this point, and we were always um, at the onset of working on unstructured data machine learning, which was seen as very future facing at the time that we had started. Language modeling and language AI was kind of in its infancy, and the thesis of the company was essentially around evaluation methods being very tedious and essentially broken for much of machine learning, and especially for the more modern neural net-esque ML pipelines, where some of the old school techniques to evaluate models simply don't work. Um, this is kind of our timeline since we started. We've always been into language modeling research, and specifically evaluation research. Here, I've shared a glimpse of our publications and published research at the bottom here. There's a lot more, of course, but this is sort of pertinent to this talk. In 2021, we started out of a language modeling lab known as the Stanford AI Lab at Stanford University. And we spent a few months there. So a lot of our origins come from a lab which has essentially produced a lot of pioneering technology in language models. From there, we went on to create DEP, which is short for data error potential. And this is a metric which was the industry's first sort of algorithmic data and noise detection metric for NLP pipelines and language models uh, prior to the chat gpt moment. Back in the day, which was about like 3 or 4 years ago at this point, people were essentially fine-tuning and training sort of BERT style models for tasks such as classification and entity recognition, entity linking, and various sort of similar related tasks. But one of the key problems was the quality of the data that you train these models on was laden with noise. So we created the first algorithmic noise detection technique, which would detect data noise, label noise, and really provide a way to up the quality of your data that you're training and evaluating your language models on. Since then, we also got into production where we built the sort of a first low latency real time language model drift detection algorithm. It was a heuristic on top of HDB scan, and we published about it and productionized it for various of our customers at that point who were using that as a means to use or detect new kinds of data that these language models would be struggling with. And from there, I think we really witnessed the proliferation of the new era of LLMs. In since then, we've published a lot of work on some of the newer problems that we are facing as the stack for uh, building these LLM based applications have evolved. The first thing we built was is a method or framework called Chainpole, which is a chain of thought based hallucination detection framework. From there, we went on to create Luna, which is a $0 or super cheap way of detecting hallucinations that uses the principles of natural language entailment. And I'll get into details of how we were able to build a hallucination detector for so cheap using these sort of first principles. And more recently, I think we focused on building what we call Luna 8 billion STP, and I'll get into what STP is. It's essentially a blazing fast, non chain of thought way of detecting hallucinations, because chain of thought has proven to be effective, but extremely costly and prohibitively high latency, especially when you're dealing with production systems. And finally, I'll talk about Luna Flow, which is sort of the most modern um, framework for metrics management, creation, and essentially spans the entire life cycle of metrics, all the way from creating it to adopting it to your data, to your use cases, and sort of making it available for others to use. And that uses a lot of the techniques which are such as Chainpole and Luna. So this is kind of the agenda, really. Like all this kind of falls under the umbrella of high efficacy methods of detecting hallucinations. So I'll start with talking about Chainpole. And in summary, Chainpole is a chain of thought based technique which uses other LLMs to determine and detect open and closed domain hallucinations. I'll go into details of why we did Chainpole, how it was inspired from LLM as judge, and how it bettered it and improved it. From there, I'll talk about Luna, which is work we did earlier in 2024, which kind of redefined or reduced the scope of hallucinations to just talking about RAG hallucinations. And we determined that or redefined that as an entailment problem, which allowed us to create these custom models which run on commodity GPUs. And they're able to measure these hallucinations for RAG use cases at the cheapest possible cost. Till date, Luna is the cheapest, most low latency hallucination detection model that is out there. From there, we evolved Luna to become much more accurate by leveraging some of the open source models. I talk a bit about that, which gets covered in Luna 8b. And finally, Luna Flow, which kind of brings it all together. And it provides this holistic framework where you can literally go ahead and create your own sort of self-defined hallucination detection technique or metric using a loose definition that you can start with a very high level definition of what you want, and from there how we use a lot of the technology and research that we've done to give you a very high accuracy metric to detect your kind of hallucinations. So let's get started with the first, which is Chainpole. Chainpole, at least back in the middle of 2023, was the most novel method of evaluating LLMs. There was kind of a time when a lot of work was being done on using other LLMs to determine if an LLM is hallucinating. And it was really leveraging the idea that the, you can use chain of thought and you can use prompting these LLMs to your advantage, and the efficacy to which you're able to detect hallucinations using other LLMs was extremely high, certainly higher than a lot of the statistical methods that were explored. And we had done months and months of research, to explore. We started with looking at how we can exploit the log probabilities to determine entropy and whether that would determine hallucinations. And slowly and steadily, we kind of evolved it to what we finally called chainpole. And kind of the summary of the performance of chainpole was that it beat out every single LLM as judge based technique at that point, um, which was sort of popular and open source, including self-check BERT scores and geval and GPT score. And it was significantly better and much more robust to different kinds of tasks. So I'll get into what chainpole, or the details of what the chainpole framework really entails. This is kind of a high level workflow which explains what chainpole does. So you start with the user's query and the prompt, and you kind of get back the LLM completion, and along with optionally log probs. I know log probabilities are not always present in, especially some of these closed API based LLMs. So if the log probs is present, what you do is you kind of send the completion and the log probs along with a chain of thought prompt. Now, this was kind of the secret sauce of the chain poll algorithm. The detailed chain of thought prompt goes into our chain of thought module. And if you don't have log probs, we built a technique of determining log probs um, using certain secret sauces. But essentially, it would give you the sort of a distribution of probabilities of the generation tokens if the original model did not give you to a certain level of accuracy. And then you pass that to a detailed chain of thought module. Now, this is where the sort of the core idea of chainpole comes. The main idea behind chainpole was that you need to use two methods to really get high efficacy hallucination detection going. Number one is chain of thought. Really ask the LLM to think step by step about the response it generated. And second, you need to do polling or ensembling. Now, one of our discoveries through our chain poll experiments was that these models are great at binary outcomes, so true and false outcomes. And this is a very important discovery because what they're not good at is asking an LLM to give a score, say between 0 and 10, versus asking it to give a true and false score. It is significantly more accurate if you pose binary questions and binary prompts to these LLMs. So chainpool essentially said that you leverage chain of thought to make the model think step by step, claim by claim for each part of the generation, but you do it n number of times, n being a hyperparameter to the framework, and each output or each round trip is essentially a binary true or false answer, kind of like each judge sitting in a room says yay or nay, and then you kind of do majority voting or some kind of an aggregate technique to the list of true and false results that you get from the chain poll algorithm. And from there, you kind of take the result, then you pass it to an optimization module, which sort of breaks down the claims from the chain of thought output and gives you a final score between 0 and 1. Uh, this is kind of chain poll in summary. I already showed you the results of chain poll. It was at that point significantly better than a lot of the LLMS judge techniques. Even till today, chain poll remains one of the most accurate LLM based LLMS judge frameworks that works well for both open and closed domain hallucinations. And the other advantage of the chain poll framework is that the two hyperparameters, namely the LLM, the judge LLM, and N, which is the polling hyperparameter, they're all plug and play. And one of the anecdotes from one of our customers is that we were able to leverage chain poll, and rather the chain poll framework was able to leverage all the innovations that were done in reducing the cost of each of these calls. Now, keep in mind that because n equal to 3 doesn't mean that we're making 3 round trips. There's a lot of um, optimizations on the engineering side that Chainpool has done to essentially cover all of this in a single LLM call. We use techniques like batch inferencing and various other methods to ensure that the number of calls you make on the wire is reduced. But the advantage was that when GPT-4 Mini came out, it was significantly cheaper than GPT, say 3.5 or 4. Uh, many of our customers using Chainpool were able to essentially halve their costs simply because the framework was plug and play. So that's just another anecdote I wanted to share. Now, this was Chainpool in summary. The next phase of, or the next technique of hallucination detection the journey that we went down was Galileo Luna. Now, Luna, unlike Chainpool, is a small model, small fine-tuned model, which essentially descopes the definition of hallucinations to only solving for RAG-based hallucination. So the standard RAG scenario is you have the user query, you have the instructions, you have context, which is usually fetched from a vector store, and then you have an output. And in this context, the definition of hallucination kind of becomes how sticky is the output to the context, or whether the sort of a measure of deviation of the output from the context. So this problem can be modeled as an entailment problem. And entailment problem basically means that it's kind of like given two pieces of text, you're trying to measure whether one entails the other or contradicts the other. It's a standard NLP a task, or a standard NLP problem prior to LLMs, and you can use these principles to sort of define hallucinations in RAG scenarios as an entailment problem. Um, Super quick, the uniqueness of Luna was that, number one, it was a multi-headed single backbone model which calibrated four RAG-based metrics, which kind of holistically give you a score of hallucination, or a measure of hallucination. Number one is context adherence, which is the measure of stickiness of the context to the generation. And then there's various other RAG based quality measures which this model measures, like chunk attribution, like which of the chunks were attributing to the output, how much of the chunks were utilized, chunk utilization, as well as completeness, how complete was the output. So you get all of this in a single pass of the model. uh, there was a lot of innovation that was done on Luna. Keep in mind that Luna is a BERT style model, so it's extremely small, which allows us to get unheard of latencies at scale. But of course, there are a lot of challenges around how do we handle the large contexts, which are more prevalent in modern day sort of LLM workflows. So there was a lot of chunking intelligence and segmentation of the data that we did. A lot of interesting feature engineering we did to be able to make the model robust to larger contexts. Like these small models, they simply don't have the ability to take in that much context. So a lot of innovation went in there. It was built in a very generalized way. There was a lot of high quality data procurement and creation that we had to do across industries. And finally, because it's a BERT style model, it's a DeBerta V3 large model, it is fine tunable on a commoditized GPU. So super cheap, super low latency, and uh, I did cover some of these the innovations that we did. Just wanted to quickly highlight. Number one, we used a novel windowing approach for better RAG hallucination detection on larger inputs. What that means is we took the input and the context and the generation, and we segmented it into segments or windows. And we behind the scenes we do a cross join uh, uh, of each segment of the generation with each segment of the context, so that we're literally able to measure at a sentence level whether each sentence is adherent to of the context is adherent to the generation or not, which really allowed us to get sentence level hallucination detection, a lot more explainability, single pass calibration of four metrics that I talked about. It is essentially a multitasking model. And there was a lot of interesting data augmentations we had to do on the Luna side to essentially deliver a lightweight neural net, which is able to give you high accuracy RAG hallucination measurements. And these are some of our results on standardized benchmark datasets. We have published the benchmark data set. It's called RagBench. You can find it on Hugging Face or on Archive. All the details are open source, and we the you can see that not only is it low cost and low latency, but it's extremely high accuracy. Now, moving to some of the more modern or newer innovations that we've done, quickly want to talk about Luna 8 billion uh, STP. Now, STP stands for single token probability. Now, in summary, what the problem that this method solves is we want to eliminate chain of thought to get the same level of accuracy, because chain of thought thinking is exorbitantly costly and very high latency, and simply doesn't work once you sort of move out of the evaluation phase and get into production. So there was a lot of thinking that we had to do, and post doing a lot of research, we found this very interesting and rather surprising discovery, which is that if you force an LLM, and it could be like a very large model, or it could be an SLM as well, like smaller language model. But if you force it to answer true and false and retrieve the token level probabilities and essentially measure hallucination as sort of one minus the log probs of the that one token that you're outputting, it gives you incredible results, almost at the level of asking a model to think step by step and chain pull or chain of thought level results. The only weakness, of course, is that uh, domains like math, where chain of thought truly shines, it is still very weak. But for a vast majority of the industry use cases where you're not really doing mathematics, it works beautifully. And I have like sort of a simple example of how STP kind of differs from chain of thought based technique. The summary is that you essentially ask the model to decide the answer immediately without thinking about it, and just ask it to say true or false, and versus in a chain poll like scenario or LLM judge like scenario where you're literally going step by step. uh, Here's some of the very interesting results. Like the orange chart that you see, or the orange curve you see, is the single token probability result, versus the blue one is the chain of thought based result. It is extremely similar for this one particular data set. And if you look at the AUPRG curves that we calculated for all our data sets, the blue and the green, they're essentially the STP based methods, versus the orange and the blue are the chain of thought based methods. So the level of efficacy and accuracy we were able to get with this technique was phenomenal. And think about it, the technique is not only it works with smaller language models, which you can host at much cheaper. The output token is essentially one single token, and the cost is exorbitantly cheaper. It is a single pass. So for those of you don't know, if you ask these LLMs to think step by step, it's not a single forward pass across the neural net, it's multiple passes, versus the STP technique is essentially just one cheap single pass, single forward pass, and you get the output at very low latency. So this is a method that scales pretty well. And finally, I want to sort of take these three methods, which I've kind of briefly described to you, and adopt it to a customized workflow, which of course the Galileo platform offers out of the box. What problem are we trying to solve? We're essentially trying to enable the users to build customized, self-authored hallucination metrics that not only work for their use case but also adapt to their data. And this is kind of the framework which summarizes how you can build a system like that. You start with the user defining, sort of giving a loose description of the kind of metric they want in natural language. For example, they want to create a metric called fairness, and they need to give like a loose definition of what that means. From there, it enters the Galileo system, where we use a prompt generation module, which is backed by research that we've published around auto prompt optimization. If you just use your search engines and type in grad sum, you should be able to find the method where we take these loose prompts and build very high quality prompts from there. And augment that with the allowing the user to upload a training or a validation data set. And the data and the auto generated prompt goes into the SLM kit, which is comprised of chainpole, the original Luna, sort of cheap Luna model, as well as the STP model. And it's all plug and play. The user can choose what they want to use, and from there, we enter a phase of validation and training where you're essentially trying to see how good the metric is on the data that you've provided. All this happens within the platform. And once you sort of achieve a certain level of accuracy, whether it's using F1, which is on the validations data, or DEP, which is Galileo's own homegrown training evaluation metric, you use a lot of these metrics within the framework to achieve a high quality or create a high quality metric, which you then store it in a metric store, load it in an inference engine, and voila, you get a new metric which you've defined purely through a loose, natural language definition of what you wanted. And want to highlight some of the gains that we've seen with many of our customers. For example, with JP Morgan Chase, we've had significant improvements in their evaluation risks and issues that they found using a lot of these techniques. Massive improvements in accuracy, and of course, all this is plugged into a beautiful centralized framework, so it allows for much faster iteration. I'm going to stop right there. There's of course a lot more to share, and I'm more than happy to answer those questions. Feel free to reach out to me at Atin at rungalileo.io. Thank you.
Yeah, thank you, Atin.
Yeah, thank you.
So I think we have two questions, and both are actually about um, getting access to information. The first one is, will copies of the slides be available?
Say again, what copies of what?
Uh, will copies of the slides be available?
Oh yeah, absolutely. I'm happy to share that after the talk.
Great. And the next question is about Luna itself. Is it open source? And can we use it for our own, I think, production projects is what that means.
Yeah, that's a good question. So Luna itself is housed within the Galileo platform. And the Galileo platform, unfortunately, is not open source, but because we mostly cater to B2B. But that said, stay tuned for in the next 2 to 3 months. We will definitely have a free version of Galileo where you can leverage Luna and Luna STP and Chainpole and all the good stuff.
Okay, so it sounds like if anyone's interested, they should definitely email you at your email address there.
Absolutely.
Great. Are there any other last minute questions? Um, oh, looks like there's a link dropped in the chat for how to get started with Galileo. So, okay, if that's it, well, thank you again, Atin. We really appreciate the talk and the tool. I think this looks fantastic, and I can't wait to check it out.
Thank you so much.
Okay, goodbye. Thanks for joining.
Thank you.